Should I change that? Should be minimized. Hello, everyone. Good morning. Yesterday we had been discussing the questions, various questions of organic chemistry, right? And this is the second day, the academic support classes. Before starting the session, I would like to tell you that this session will be more interactive, and I expect each school to give your messages, your answer in the form of messages, either the host or everyone, right? So that I can see the arrangement is made today to see the messages of you, so that I can able to get the information from each school, right? So chemistry is the one which needs oftenly revision, and especially in the organic chemistry, we need to revise more oftenly, and so that we'll remember it and recall it at the time of examination, right? Now, yesterday I stopped at one of the question which was taken from the sample papers of CBSE. Solving the question paper, sample paper is important, as this is going to give you what is an examiner's mind, and also what is the ultimate level that we have to reach, right? And what are the things to be revised properly. To get this idea, you should have in touch with the sample papers, right? The word problems, in the word problems, it was a lengthy one. Then I have taken it from the CBSE sample paper. An organic compound with molecular formula C7H7NO2 exists in 3 isomeric forms. They have given a molecular formula of a compound and said that it is existing in 3 isomeric form. The isomer A has the highest melting point. Out of that, we have to choose one isomer which is having highest melting point. A on reduction gives compound B. A on reduction gives compound B with the molecular formula C7H9N. B on treatment with NaNO2HCl at 0 to 5 degrees Celsius to form a compound C. On treating C with H3PO2, it gets converted into D with the formula C7H8, which on further reaction with chromyl chloride CrO2Cl2 followed by hydrolysis forms E, C7H6O. That is the molecular formula of E. Write the structure of the compound A to E and write the chemical equations involved in it. It is a 5-mark question. Okay, comprehending this is very important thing. So let us take up this information now. An organic compound with molecular formula C7H7NO2 exists in 3 isomeric forms. So isomer A has highest melting point, NO2. This is C7H7NO2. So look at the ratio of carbon and hydrogen. Ratio of carbon and hydrogen is giving you the idea that whether it is a benzene ring is present. C6H6 is benzene ring. C6H6 is the molecular formula of the benzene, right? And if it is an alkane, CnH2n plus 2, one of the hydrogen might have been replaced by some other group, or two of the hydrogens may be replaced by some other group. Therefore, the ratio will be almost double. Carbon and hydrogen ratio is almost double. But here, the carbon ratio and hydrogen ratio is almost same, means it must be having a benzene ring. Okay, if it is having a benzene ring, right, then this is having C6H6. There must be one more carbon atom. That means there may be a methyl group. You can think there may be a methyl group attached to the benzene ring. And there is NO2 also. So there is NO2 and methyl group may be present here. This is called ortho position, right? Is the board visible? Okay. This is at ortho position. There is another isomer, right? NO2 can be there in meta position. And there is one more which can be in para position. So the three isomeric forms, they mean it is so. It exists in three isomeric form. Okay. Now, actually, this molecular formula can have another isomer also, CH2NO2. Let me just check whether this holds good. This is C6, H1, 2, 3, 4, 5, 5 plus 2, 7, and NO2. So this also can be an isomer, but they have given that it is only having three isomeric forms. It is also can be written as one of the isomer. But among this, which isomer is having highest melting point? See, a small, simple observation of physical property is also asked in this form. It is a physical property. And you know that the one which is a para isomer is having more melting point. Because whenever the para position, the substituent is there, it is symmetrical and stacking of the compound one over the other is possible easily. Or they are close. Whenever they are close, they have got greater van der Waals force of attraction and therefore the melting point is high. This happens in the case of melting point, right? Stacking of the particles is possible or more readily it possible whenever it is having symmetry, right? Now these are the three isomeric forms of this, and this is the one we have to choose because the A has the melting point. A has the melting point of the three. A has the highest melting point out of three. Now coming to the second phrase of the question. Now we know that this is the compound. Probably we guess that this is the compound NO2 and CH3, right? Now this compound gives B on reduction. B with molecular formula C7H9N. Reduction. Reduction means what? Reduction is removal of oxygen and addition of hydrogen. So this is not undergoing reduction, and this benzene ring doesn't undergo a reduction. Only this undergo reduction. Therefore, it could be NH2, right? So this gives aniline or 4-methyl aniline. So tally with the molecular formula always. Okay, C7H9N. So C1, 6 carbon atom in the benzene ring and one more. C7 is over. Hydrogen 1, 2, 3, 4 from the benzene ring. 4 plus 3, 7. 7 plus 2, 9. H should be 9. Okay. And nitrogen, 1 nitrogen. Therefore, it tallies with the molecular formula this. Right. Now, be on treatment with NaNO2HCl. Very important reagent, NaNO2HCl. So, always aniline with this reagent, it forms a diazonium salt. Benzene diazonium halide, right? So this will give NaNO2HCl. So NaNO2 plus HCl at lower temperature, 0 to 5 degrees Celsius, 0 to 5 degrees Celsius. Okay. So this will give benzene diazonium chloride. So other methyl group which is present here is not affected. Only NH2 is affected. N2Cl. It becomes NH2 becomes N2Cl. So what we have found out? We have found out the molecular formula of A, structural formula of A and structural formula of the B, and B on treatment with form compound C. A, B, C, right? So now another phrase, on treating C with H3PO2. On treating C, let us again write what is C. I will write here. So this is diazonium chloride, N2Cl and CH3, right? And this with H3PO2, H3PO2, phosphorus acid, hypophosphorus acid, H3PO2 or ethyl alcohol. This diazonium salt is converted into a benzene ring. A benzene diazonium chloride is converted into benzene ring. Therefore, this will be having only methyl group at this position, right? H3PO2 will convert this into a benzene ring. This nitrogen N2, N triple bond N leaves as N2 gas. Now this is D, right? On treatment C with H3PO2, it gets converted into D with the molecular formula C7H8. This should be C7H8, C carbon 6 and H5 plus 3 8, right? Which on further reaction with CrO2Cl2 chromyl chloride, right? With CrO2 followed by the hydrolysis, that means H2O, H2OH plus this hydrolysis, it will give a compound C7H6O. So you have studied that toluene or methyl benzene on oxidation with chromyl chloride in CS2 will give benzaldehyde, right? This is the method of preparation of benzaldehyde, right? And this is Itard reaction also. This is Itard reagent, Itard reaction. Okay, in that way, it is written in the small letters in the textbook. This is a Itard reaction. So whether it matches or not, C7, C6 plus 1, C7 is okay. H6, H5 plus 1, 6, okay. Oxygen 1. So that it tallies. So these are the compounds which are being meant there. And you have to draw the structural formula of it and also write the reaction as it is told here, right? So each reaction to be written separately so that you can able to get into that. Okay. So A, B, C, D, E, all structural formula and the reactions are asked. This for one question for 5 marks, right? Fine. Now, thought of discussing the objective type questions, right? So are you all ready? Are you all ready for objective type questions? So all of you just put a message, hi. If you are ready, we'll go ahead. So enter into the, what the condition required is, you have to enter into the Zoom meet so that you will get the message. But in the YouTube messages, that lag 10 seconds. And after asking the question immediately, if your answer will not be reached here, so that is the problem with when you are connecting with YouTube. If you have connected with Zoom meet, we can able to discuss the questions, or you can give the responses, and many answers you may have, or I can understand what is the difficulty of you, right? Why you have done mistake, or if the many are doing mistakes, we can able to find out where the mistake is, right? There that needs a clarification, or there that need is more input. So in this way, I hope all of you are there in the class, can give responses. Yeah. So this is JNV Bidar. Thank you. Fine. JNV Bidar responded. Come on. Any other? If any teacher is there with you, you can use the mobile for half an hour or so. Just try that and put a message. Okay, somebody is hello, hello. Please try. I can listen to you. Okay, you can switch on the mic also and you can say the answer. Doesn't matter. If this giving message is not possible, you can give this. Okay, you can talk and give the voice. Right. Okay, fine. Fine. Okay, chapter wise, let me go for taking up the questions of objective type questions. So objective type questions about 18. Now it is reduced to 16. 16 questions are there. Yes. Any problem? You want to say anything? Yes, JNV North Canara is there. Okay. JNV Chara is there, right? Okay, I'm not getting the messages. I don't know what is the problem with. Okay. Okay, fine. Oh, we'll begin. I don't know what is the facility there at your school. We will take up the next questions, right? So the flow will go now.
Okay. We'll begin. I don't know what is the facility there at your school.
Which of the following is a primary halide? Isopropyl iodide, secondary butyl iodide, tertiary butyl bromide, neohexyl chloride. This is the question. Which of the following is a primary halide? Isopropyl iodide. You can just type A, B, C, or D. Isopropyl iodide. Profile C. Isopropyl is having the second carbon, iodine, right? This is isopropyl. Sec-butyl iodide. This is I. Sec-butyl. Secondary butyl. The carbon is sec-butyl. Tertiary butyl. In the same way, write the structure and see which is primary halide. Anybody orally can say? Yes? What's your answer? Loudly. Okay, tertiary butyl. Tertiary butyl is
okay. D, sir. D.
D. Very good. Very good. Which school? Okay. Tertiary butyl. Okay, one of this should be I. This is I, right? This is I. This is tertiary butyl. And neohexyl is having this skeleton. This is neopentyl and neohexyl iodide. 1, 2, 3, 4, 5, 6. Neohexyl iodide is primary because it is attached to this carbon atom. This is having CH2. Okay. So this is the answer. So good. Neohexyl chloride or iodide. Neohexyl chloride. Okay, it's not iodide, it's chloride. Right. Gem dibromide is CH3 CHBr CH2Br CH3 CBr2 CH3 CH2Br
B, sir.
It should be CH3, okay? CH2Br CH2Br.
Sir.
Yeah. What's your answer?
Sir, B, sir.
Okay, B. JNV? Is it JNV Dharwad?
Sir, option B.
Okay, option B. Option B is the right answer. This is B is the answer, right? So gem dibromides are those which are having both the bromine attached to the same carbon atom. This is gem dibromide. Okay, CH3, CBr2, CH3. Gem bromides are those which are having both the bromine halogen atom to the one carbon atom. Here, bromine is to the two adjacent carbon atoms. What is the name for that kind of compounds in which adjacent carbons are having two bromine?
Vicinal.
Vicinal dihalide.
Vicinal dihalide. Good. Vicinal dihalide. Right. CX bond is strongest in. CS bond is strongest in. CX bond. CX
C, sir.
are CH3F and CH3I.
CH3F, sir.
CH3F, right? CH3F.
C, sir.
Why it is stronger? Why it is stronger? CH3F. Okay. CH3Cl. CH3Br. CH3I. Okay. So fluorine, chlorine, as the atom size increases, the bond length increases, bond strength decreases. So this is the right answer. CH3F, right? Now, IUPAC name of CH3 thrice CCl is the IUPAC name of this. Clue. You have to write like this.
B answer. B.
Sir, option C.
Option B.
Right? IUPAC name. Yeah. Oh, somebody
Option
told
B,
that
sir. Option
C is
B.
the answer. C is also the answer, but is the name of it, but it is not the answer. Because IUPAC name, when it is asked, you have to choose the longest carbon-carbon chain, right? So this is likely to happen in objective type questions. Okay, don't be in a hurry. So this is tertiary butyl chloride, right? Tertiary butyl chloride is right, but IUPAC name is longest carbon-carbon chain. You have to choose first carbon atom, second carbon atom, third carbon atom. 2-chloro-2-methyl. Therefore, 2-chloro-2-methyl propane is the answer, right? Fine. Now, in which of the following conversions phosphorus pentachloride is used as a reagent? Phosphorus pentachloride, PCl5.
Option B. Option B, sir. Option B.
Okay. Is it JNV Dharwad?
Sir, JNV Chikmagalur.
JNV
Dharwad also, sir.
Okay, JNV Dharwad, JNV Chikmagalur. Good. You are responding well. Other schools also may join, right? Make some noise. Make some noise, right? CH2, CH2 to CH3, CH3, CH2Cl. Here we need HCl. Okay, here H is added and the Cl is added here. Okay, so CH3, CH2, not PCl5. Here, alcohol to alkyl halide. This is there, alcohol to alkyl halide. This is ether to this. This cannot be possible. And ethine to, again, ethene. Here also HCl is added. So that option B is the right answer. Okay, 2-chloro-2-methyl propane. Right. Okay. Right. Okay, the Grignard reagent may be made by reacting magnesium with Grignard reagent, simple.
Sir, option B.
Option B.
Option C.
Okay.
Option C.
Yes. Option C. Right. Grignard reagent is RMGX. This is RMGX. And with magnesium, What is to be reacted is Rx. Rx, when reacts with magnesium, we get RMgX. Okay. In ethereal medium, okay, in ether is to be used because Grignard reagent is reactive towards carbon dioxide, moisture, and so on. And therefore, this is not an ether, this is ethyl iodide, right? Ethyl iodide, right? Good response. Come on. Which one is most reactive towards SN1 reaction? Which is most reactive towards SN1 reaction?
Sir, option C.
Option C.
Option C, sir.
Option C. Well,
Sir, option C.
anybody? Okay, you can see. If you have any other answer also, you can tell. No problem. So for the SN1, 3 degree, tertiary is more reactive than secondary, than primary. This is the key thing to be remembered, right? And this carbon here is having substituents. Okay, so one benzene ring, another one is having another benzene ring. This is C6H5 and another CH3 and Br, right? So sometime it will be given in this way in the examination. Draw that if it is needed and identify that there is a tertiary carbon atom and this is more reactive, right? The order of reactivity of the given haloalkanes towards nucleophile is?
Option A.
Option A. Very quick. You are very quick. Good. Ri is more reactive than RBr than RCl, right? So the order of reactivity of the given haloalkanes towards, right? Any other answer? Yes, any other answer? So this is Ri is more than RBr than RCl. Ri in I is a better leaving group and I is there, therefore the nucleophile is being formed, right? Now more reactive halide towards SN2 reaction is? More reactive halide towards SN2 reaction?
A, sir.
Yes, sir.
Option A.
Yes. Look at this. There is again D also is there.
Option A. D, sir.
Chloride. Allyl chloride is something like this. CH3, CH double bond CH, CH2Cl, something like this. Allyl chloride. This is also primary. N-butyl chloride. CH3, CH2, 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 Cl. This is also primary. I think you need to think.
D, sir.
Okay, SN2, primary, secondary, and tertiary. This is the order. Sec-butyl is secondary. Sec, already it is there. Tertiary, this is tertiary. Now tell me, with this information, which should be the answer? Among 1, A and D, which should be the answer?
A. A.
Okay, A should be the answer. Right, A should be the answer. Because even though it is a primary halide, the key thing that I have told is, even though it is a primary halide, this is allylic and it forms allylic carbocation. Once it does allylic carbocation by the cleavage of this is stabilized by resonance. Whenever a carbocation formed is stabilized, then SN1 path it will go. Therefore, this is not the right option, right? Allyl chloride is not the right option. Okay, that is where the difference is. In SN1 reaction, the racemization takes place. It is due to, in SN1 reaction, racemization takes place.
Option D.
Inversion in configuration,
Option D.
retention in configuration, conversion in configuration, both A and B.
Option D.
Option D, right? So option D is the right answer. It is because there is inversion in configuration and retention, both takes place. Okay, if a compound is dextrorotatory, and it has to form dextrorotatory compound and levorotatory compound, both. If both are there in equal quantity, then racemization occurs. So the question is asked in this way: both A and B means the equal quantity of these two takes place. Both takes place, right? Both A and B, right? SN2 mechanism proceeds through intervention of carbonium
Transition
ion,
state.
Transition state.
transition state, free radical, carbon ion.
Transition state.
Yeah.
Option B.
Option B, right? So which school is responded this? Is it Chikmagalur?
Yes, sir.
Yeah,
JNV
fine,
Kadapa,
fine.
sir.
Yeah, SN2 mechanism proceeds through intervention. That is, remember, in SN2, there is incoming nucleophile and there is outgoing nucleophile. This was the example that I have taken. This is called a transition state. Okay, the carbon has to leave the nucleophile and another nucleophile should enter in, and this state is a transition state. Both the incoming nucleophile and the haloalkane is present, therefore it is bimolecular. SN2 bimolecular because both the incoming nucleophile and the outgoing nucleophile or the substrate haloalkane is present in the rate determining step, therefore it is SN2, right? So you're right, transition state is the right answer. Which of the following compounds is optically active? Which of the following compounds is optically active?
Yes, sir.
Option A.
Yes, sir.
Option A.
Option A.
Yes, sir.
Yes, sir.
Yeah.
Option A.
Option A. A compound is optically active if the carbon is chiral. Say in option A, this carbon is optical center or the chiral center. This has a CH3 and one H and another Cl and another COOH. Right? This carbon is having HCl COH. Okay. So always whenever it is written in this order, it is confusing. But some of you have told the answer without getting confusion. That's good, well and good. And if the carbon is having 4 different constituents, this is optically active. So your answer is correct. So this is the correct answer. Now, an alkyl halide reacts with metallic sodium in dry ether. The reaction is known as
Woods reaction.
Option B, sir.
halide with metallic sodium. What is this reaction?
Option C, sir.
Wood reaction.
Yes, it is Woods reaction, right? It is Woods reaction. Okay, alkyl halide, right? Plus sodium. This gives RR plus NaX, right? With sodium in ether, it will give a hydrocarbon, right? Recall in this way so that you will remember forever, right? When 2-bromobutane reacts with alcoholic KOH, 2-bromobutane reacts with alcoholic KOH, the reaction is called
Option D.
D, sir.
Dehydrohalogenation, sir. Option D.
Option D, dehydrohalogenation. Okay, 2-bromobutane, 2-bromobutane. This is 2-bromobutane. Okay, and this when reacts with alcoholic KOH, then this bromine and this H is likely to go over, or this hydrogen, because there are 2 beta hydrogen, right? Beta elimination takes place. Alcoholic KOH is known for beta elimination, right? So either this here or this hydrogen goes away. Hydrogen and halogen both goes away. Therefore, it is dehydrohalogenation. Dehydrohalogenation reaction, right? Now connect sulfonation of C6H5Cl. Sulfonation of C6H5Cl. What is the compound form? Benzene sulfonic acid is formed. Metachlorobenzene sulfonic acid is formed.
Option D.
Orthochlorobenzene sulfonic acid is formed. Ortho and parachlorobenzene sulfonic acid is formed.
Option D, sir.
Option D, sir.
D. Option D is right answer because chlorine is ortho-para directing. So this has got plus R effect, inductive effect. Those which are attached to the benzene ring, which are which are having plus R effect, resonance effect, they are ortho-para directing for the incoming electrophile. Okay. So therefore, this is both ortho-para chloro compounds are obtained. Right. Now, CCl bond of the chlorobenzene in comparison with CCl bond in methyl chloride is longer and weaker, shorter and weaker, shorter and stronger,
Option C,
longer
sir.
and stronger. Confusing.
Option C, sir.
Correctly and do that.
Option C, sir.
Option C. Very sure? Chlorobenzene.
Option C, sir.
This is chlorobenzene, right? Here CCl bond, methyl chloride. Okay, this is carbon chlorine bond. So which is shorter among these two and why?
Partial double bond
is
character.
shorter because it is having double bond character. Okay, double bond character, this is shorter and this is longer. So shorter CCl bond of the chlorobenzene in the comparison of CCl, it is shorter. So out of these two. So whichever is shorter, this should be stronger also. Bond length is less, then it is more stronger. Shorter and stronger, right? Okay, both properties are being asked here and you are right. Good, your response is good and keep it up. Go ahead, keep doing. Others also have to try. Don't think that one is saying the answer and you keep quiet. Okay, you can put the messages, right? I will wait for it. Which one of the following is most reactive towards nucleophilic substitution reaction?
C, sir.
Which one of the following is most reactive towards nucleophilic
C,
substitution
sir.
reaction? Okay. Let others think for a while. Nucleophilic substitution reaction. Okay, the better thing is that if in SN1 path, if it is asked, that is better question. If it is in SN1.
Option C, sir.
Option C. Okay, I will give you more ideas. Here, chlorine is attached to sp2 hybridized carbon of the benzene ring. These are called vinylic halides. Vinylic halides. And this is attached to the benzene ring itself. This is chlorobenzene. Chlorobenzene. And this is also sp2 only. This is also vinylic halide. Okay, this is also vinylic halide. Here, this is attached to sp2. In turn, it is attached to sp3. Right? This carbon is sp2 and chlorine which is attached to the carbon is sp3. This is allylic. Allylic. Allylic halides are more reactive. Okay. Allylic and benzylic halides. So this is chlorobenzene, not benzylic halide. Benzylic halide is this. This is usually usual mistake happens here. This is benzylic halide. And this is chlorobenzene. Chlorobenzene is not more reactive because it is a double bond character and it won't leave. Cl doesn't leave as Cl minus. And therefore it is allylic halide. So D is the right option. Okay. Some of you have told the answer, right? You are in right path. Now, benzene reacts with CH3Cl in the presence of anhydrous AlCl3 to form. It is not there.
So D, sir.
D. Okay. Okay, benzene. Benzene. Okay.
Sir, Tobin.
Okay. CH3, presence of anhydrous Cl. Benzene reacts with CH3Cl, AlCl3. So what it should give? So this is an electrophilic substitution. Cl will go to electron deficit AlCl3 to form AlCl4 minus ion, and electrophile CH3 plus is generated. This electrophile is substituted. Okay, H goes away from some position and this. So C6H5CH3 is toluene. Therefore, toluene is the answer of this. Right. You are right. Haloarenes are orthopara directing due to. Haloarenes are orthopara directing due to.
Yes, sir.
Confusing? Is it both A
Option
and
D.
B? Haloarenes
Option
are
D.
orthopara directing.
Resonance effects.
Option C.
Option C.
Option D.
Option D. Right. This is a confusing question. Right. So resonance effect is this is resonance effect, due to which it takes double bond character and the ortho and para position is electron rich. Right. So this is double bond, and suppose if I write this, okay, the answer has come. Okay, I will. Okay, I have to take this. Resonance effect is a reason is only the resonance effect. It is because the ortho para position will be electron rich due to resonance plus R effect. Minus I effect of halogen is present, but this is not responsible for making it orthopara directing. Okay, so both A and B, in the case chlorobenzene, it has these effects, but one which is responsible for orthopara directing is only resonance effect. Therefore, this is the correct option, right? So because of the minus effect of halogen atom, it acts as a deactivator for the benzene ring to undergo electrophilic substitution reaction. Okay. So that's the thing. Now, which one of the following is used as a fire extinguisher?
Option D, sir. Option D, sir.
D, sure.
Option D.
Okay, what is its
Option D,
commercial
sir.
name called as? What is its commercial name? You know that this is sold as pyrene. Pyrene, fire extinguisher, right? CCl4. Carbon tetrachloride is sold as pyrene and it is a fire extinguisher. You are right. Your answer is right. CCl4. Yes? Right. Correct. Good. When chloroform is exposed to light and air, it forms.
C, sir.
Option C.
Yeah. Chloroform exposed to air. This is phosgene. Yes. Chlorine gas is not poisonous, right? It is a poisonous gas. Phosgene is a poisonous gas. Chloroform exposed, therefore it should, the lid is to be, if it is lid is closed also, we should not open the lid of the chloroform, okay, directly, because phosgene is a poison gas which will be present after the oxidation of chloroform, right? Chloroform is CHCl3, right? On oxidation, it gives, okay, Cl and Cl. This is ClCl. CClO. So this is the phosgene. It's a poisonous gas, right? Okay, fine. Now, IUPAC name of the compound shown below is, okay, here double bond is there, right? Double bond. Para position, bromine and...
Option D, sir.
Sorry, not para.
Option D. Sir.
Yeah, option D, sir.
Sure? Or option C? Okay. So the one which is one alkene, since alkene is there, the carbon including that double bond will become the first carbon atom. This is the first carbon atom. right? This will be the first carbon atom. This is the second carbon atom. This is the third carbon atom. Because alkene is to be given more importance, right? So one bromo, 3 chloro, cyclohexene. Yeah. So D is the right answer. D is the right answer. Okay, fine, good. Okay, so this is about the chapter haloalkanes and haloarenes. Okay, so this is level 1 questions. Probably the questions that I have chosen is for the participation of you. It is also, and it is not very difficult questions and all. Okay, if you have already tried with it, if you are already happen to see all these objective type questions, go ahead for the level 2 and level 3 type of questions, right? Okay, so you are likely to get some easy questions maybe in the pre-board examinations or so, pre-board 1, but pre-board 2 will be difficult. So it will be at par with CBSE examinations, and therefore always follow the questions of CBSE sample paper. Let me discuss all the CBSE sample papers also in the later phase of it, right? Now coming to this chapter, the compound OHCH2CH2OH is
Option D, sir. Option B, sir.
yeah.
B.
You want to
Ethylene
correct?
glycol.
So it is not asked IUPAC name. It is ethylene glycol. Ethylene glycol is CH2OH, written in a different ways. CH2OH, CH2OH, right? Glycols are those which are having 2 hydroxy group, right? Diols. Okay, this is ethane 1,2-diol. IUPAC name is ethane 1,2-diol. But in the common name, there is ene, confusing. It is not double bond. It is not telling anything about the double bond. It is not IUPAC name. Ethylene glycol is the right answer. Okay. IUPAC name of M-cresol is metacresol.
Option A, sir.
Option A. 2. Meta position. 2 will come. Okay, this is a benzene ring. Okay.
D, sir.
Suppose if there is OH for the phenol, this is one carbon atom. The second carbon atom. Meta is here, right? Right? Cresol. So the options A and D can be eliminated, right?
3-methylphenol.
Option C, 3-methyl.
Okay. So 3-methyl phenol, it is 3-methyl. What is that? Okay, so answer, it is some change is there. It is actually 3-methyl phenol, 3-methyl, right? Not 3-methoxy, 3-methyl. I think I have written 2-methyl here in the answer question, therefore it may be confusing. Right, ignore that and we'll go ahead. Acid catalyzed hydration of alkenes except ethene leads to the formation of acid catalyzed hydration of alkenes except ethene leads to formation of primary alcohol, secondary alcohol, or tertiary alcohol, mixture of primary and secondary
B, sir.
alcohols.
Option is
Option A, little confusing, little confusion is there. Acid catalyzed hydration of alkenes. Suppose I will take some unsymmetrical alkene, right? This is propene, unsymmetrical alkene. Acid catalyzed hydration. This is H2O in the presence of H+. The OH group goes to which carbon atom here? As if it is Markovnikov addition is taking place, right? This is the word I have used yesterday. H adds here and OH adds up here. So this is as if anti-Markovnikov rule, negative part of the addendum. This you can be taken for a OH minus ion. Okay, but anti-Markovnikov rule is only for HBr. But for remembering, I am using that word, right? Acid catalyzed hydration of alkene except ethene. For ethene, it leads to, for ethene, CH2, and when it H2O is added, for one carbon atom, H should be added, and another carbon atom, OH should be added. So it becomes primary only. For this, it should be secondary. And if it is unsymmetrical alkene having this CH3, CH3, double bond CH2. If this is so, instead of H, there is again CH3. Right? Then OH should be added to here, this carbon atom. If OH is added here, CH3, CH3, OH, and CH3. H is added here and OH. Remember, as if Markovnikov addition is being followed, OH is added here. And this is secondary or this is tertiary. So either secondary or tertiary is being made, not mixture. It is not a mixture. Because if this compound is taken, it will be secondary. If this compound is taken, it will be tertiary. Therefore, B is the right option. B is the right option. Secondary or tertiary, one of this, not a mixture, right? Ethyl alcohol can be prepared from Grignard reagent by the reaction of ethyl alcohol can be prepared. Ethyl alcohol can be prepared.
Yes.
Ethyl alcohol can be prepared by the reaction.
Sir.
Formaldehyde, sir. Option A.
Yeah. Formaldehyde, HCHO. Is it right? What is the Grignard reagent? What is the Grignard reagent used here? Can you tell me which is the Grignard reagent used? This logic is important. HCHO is having one carbon atom, and the another carbon atom should come from Grignard reagent.
Methyl magnesium bromide.
Grignard reagent, it should be
Methyl magnesium bromide.
very good. Methyl magnesium bromide. Okay, and how you could able to tell this answer so quickly without thinking about all these things? So some generalization made you remember. Generalization, remember, formaldehyde will give always primary alcohol. Okay, and any other aldehyde then formaldehyde will give secondary alcohol with Grignard reagent. And ketones will give tertiary alcohols. This is a very important generalization. If you know the generalization, you can attempt such question quickly. The person who has told has remembering this generalization, right? Or else you have to try with that initially and you have to find out. If there is 2 carbon atom with alcohol or if the primary, then formaldehyde is to be chosen. Formaldehyde is to be chosen, right? Fine. Which of the following is not true in the case of reaction with heated copper at 300 degrees Celsius? Heated copper at 300 degrees Celsius.
Option A, sir.
Option A.
Option
Yes.
A is not true. Okay. Fine. So this is copper at 573 Kelvin. This is the way that is being given. 573 Kelvin. Because 300 degrees Celsius is 573 Kelvin. Copper at 573 Kelvin. Okay. So it is a reagent which is used for removing hydrogen, right? From the alcohols. Right? It is a dehydrogenating agent. Copper at 573 Kelvin. Secondary alcohols are like this. Secondary alcohols, say, I will give the example. Secondary alcohol, on removal of this hydrogen, it becomes ketone. CH3, C double bond O, CH3, right? CH3, C double bond O, CH3. This becomes ketone. Primary alcohols in the same way will give aldehyde. Tertiary alcohols, there is a typicality. Tertiary alcohols This is not CH. C. This is tertiary alcohol. But tertiary alcohol, there is no hydrogen at all. OH and H is not removed in this way. Okay. So what happens is OH and this hydrogen is eliminated. That means there will be double bond. So C double bond CH2. Okay. So this H and this OH will go, not this H. Therefore, olefin, that is alkene, is obtained. Copper at 573 Kelvin. Secondary alcohols will give ketones. Primary alcohols aldehyde. Tertiary alcohols will give olefins, but means double bond. One which is having double bond, olefins. Right. But phenol to benzyl alcohol is impossibility. Phenol is this. Okay. And benzyl alcohol is CH2OH. Phenol to benzyl alcohol, how this carbon atom comes with this reagent? No, not possible. Therefore, this can be eliminated easily. Okay. But this is the point to remember. Some generalizations that you have to make here. So remembering, okay, what all the very basic things you have to remember that are there in such questions, in these questions, right? So this is the wrong thing, right? Phenol is more acidic than alcohol because phenol is more acidic than alcohol. Phenol is more stable than water. Phenol is
Option C, sir.
alcohol, aliphatic.
Option B.
B. Phenol is more acidic than alcohol.
C, sir.
Phenoxide ion is resonance stabilized.
Option C, sir.
Option
C.
C. Yeah, this is a well understood topic, I believe, because phenol gets stabilized by phenoxide ion. Stability of this leads to the higher Ka value of this particular compound. But whereas alcohols are O minus plus H plus. Oxide ion is less stable because oxygen is having negative sign. This is electron releasing. So this reaction is more dominant. Okay. So leads to lesser Ka value of ionization constant of alcohols. So since this is more, why this Ka is more or phenol is more acidic? Because of the phenoxide ion is resonance stabilized, right? So therefore this is the answer, right? Good. You are all in good form. Fine. Chikmagalur. And okay, others can give the response, right? In the form of messages or so.
C, sir.
Okay, I have already shown you the answer. Let me. Which one of the following alcohol is least soluble in water? Right. Your answer is right because the alcohol in which
More number of carbon atoms, sir.
yeah, more number of carbon atoms are there means increased number of carbon atoms, the hydrophobic group increases. So the hydrophobic group increases, then the solubility decreases. Right. So least soluble one is this. Right. Good. Okay. Fine. Methanol and ethanol are miscible in water due to methanol and ethanol.
Hydrogen bond.
B, sir.
Yes, it is because methanol right, and ethanol. Okay, both are having hydrogen bonding. Hydrogen bonding. Okay, so the oxygen of the water, okay, get attracted. This is doing hydrogen bonding with water. Okay, or solubility, the formula or the very important thing to be remembered is like dissolves like. Okay, the dipole moment or this is also having hydrogen bonding. Water is also having hydrogen bonding. Methyl and ethyl alcohol also hydrogen bonding. Therefore, they are miscible in water. Right. So hydrogen bonding character. When ethyl alcohol reacts with acetic acid, the products formed are ethyl alcohol reacts with acetic acid.
Ethyl acetate plus water, sir. Option B.
Ethyl alcohol. Okay, fine. Ethyl alcohol reacts with acetic acid. Okay, now look at that. What is the product?
B, sir.
B? Sure? Okay, this is a typical reaction. From the carboxylic acid, OH will go. And from this, H will go. H2O. It is called esterification reaction. CH3CO from carboxylic acid and ethoxide ion OCH2CH3 forms an ester. This is an ester. So this is named as ethyl ethanoate. Ethyl ethanoate and water. So it is an ester, ethyl acetate, or you can call it as ethyl acetate. Common name is ethyl acetate. Okay, and water. Therefore, B is the right option. HBr reacts faster with 2-methyl propanol, propane 1-ol, 2-methyl propane 2-ol, propane 2-ol. This E is not needed. Propane 2-ol, propane 1-ol.
Option B.
Option B.
B, sir. B.
B.
2-methyl propane 2-ol.
Propane 2-ol. Why you have chosen B? Why you have chosen B? Always, in case of alcohols, 3-degree alcohols are more reactive than secondary than primary. This is order of reactivity of alcohols with the alkyl halides. Again, just as SN1. Okay, so this is 2-methyl propane 2-ol. This means CH3 propane 2-ol OH and methyl group both are there here, and CH3. 2-methyl propane. This is propane, 2-methyl propane 2-ol. This is a tertiary alcohol. So since tertiary alcohol is more reactive, therefore HBr reacts fastest with. Okay. Now, ethyl alcohol exhibits acidic character on reacting with. Acidic character on reacting with acetic acid, sodium metal, hydrogen chloride, acidic K2SR2O7.
Option B, sir. Sodium metal.
B, sir.
Okay.
Option B, sir.
Option B, sure? Right. Why do you say the options B? Ethyl alcohol, CH3, CH2OH, ethyl alcohol. Okay. So to show its acidic character, you need to react with sodium so that you get a salt, CH3, CH2ONA, this is salt, plus hydrogen gas. So anything reacts with a metal to give hydrogen, we believe that as is an acid, right? So therefore, ethyl alcohol is considered as an acid, right? Because of this reaction. Okay, it is typical, no, it is a typical way of looking at the things. Ethyl alcohol is less that acidic than water. Look at this. Ethyl alcohol is less acidic than water, and phenol is more acidic than water. Or ethyl alcohol, okay, acidic character is less than that of water, and the phenol is more acidic among all these things. These are all based on Ka value. Okay, don't go for the litmus test. Okay, it is an alcohol, it is a acid, therefore it should turn blue litmus into red. It is not so. Even water doesn't give. But depending upon ionization constant, Ka value, right, we'll give whether this reaction happens or not. Okay, well, the Ka value decides that, and the Ka value is smaller here, is more here, and this is the most here in the phenol. So sodium metal reaction with sodium metal gives hydrogen, therefore it is considered as acid. Okay, some generalizations are made in this way. Right. Lucas reagent is concentrated HCl and anhydrous zinc chloride.
A, sir.
HCl and anhydrous ZnCl.
Yes.
Okay.
Option A, sir.
Hydrous or anhydrous? See, look at this. Constant HNO3 and anhydrous zinc chloride. Okay. This
A,
option
sir.
A. Option A is the right answer. HCl. Okay. Lucas reagent is used for conversion of alcohol. Say ethyl alcohol, if I take, it is converted into CH3, CH2, Cl. So HCl, make the change, right? And why the anhydrous zinc chloride is needed? Anhydrous zinc chloride is a dehydrating agent. There is another product called H2O. There is another product H2O. And to remove this H2O, this anhydrous zinc chloride is needed. And you know that from Le Chatelier's principle, in any equilibrium, if the product is removed, more reactants are being formed. That's why this is used as a catalyst. It increases the process, increases the speed of the reaction, increases the output. Therefore, anhydrous zinc chloride is being used. Right. Aspirin is acetylation product of. Good question. Aspirin, you should know the formula.
Option B, sir.
B. Very good. Aspirin. Aspirin is this is okay. Sorry, this is COH and OCOCH3. This is 2-acetoxy benzoic acid. 2-acetoxy benzoic acid is aspirin.
Please.
Right. So this is obtained by acetylation of. So acetylation to be done to the compound, for which COH should remain as it is. And here there must be change. So acetylation occurs by adding CH3COCl or CH3CO twice O, acetic anhydride or acetyl chloride. So it should be a functional group having OH. When only OH reacts with this, or OH reacts with acetyl chloride, esterification occurs. This is an ester. OCOCH3. This is an ester, right? Aspirin is an ester, all right. Esteric group is there and carboxylic acid also is there. Therefore, this is the one that is asked. So it is salicylic acid or it is orthohydroxybenzoic acid. So this is the first carbon atom, this is the second carbon atom. 2-hydroxybenzoic acid or orthohydroxybenzoic acid. So that is the way that you have to. Right. When phenol is heated with CHCl3 and KOH, when salicylaldehyde is produced, this reaction is known as?
Please.
Option B, sir.
Yes. Okay. Option D can be does not come to your class at all. So remember, there are two things which you have to immediately remember is phenol with CO2 and NaOH and phenol with CHCl3 and NaOH. Okay. So CO2 NaOH, Coles reaction, salicylic acid. CHCl3 NaOH, salicylaldehyde, right? Salicylic acid, OH, COH, right? And salicylaldehyde, OH, CHO. So salicylaldehyde is being asked. This is Raymer-Tiemann reaction. So option B is the right answer. So good. Keep it up. Go ahead. Methanol, ethanol can be distinguished by the following. Methanol and ethanol.
Option C, sir.
Okay. It's good. Good amount of discussion is going on. It's always good.
C.
And the one who is saying the answer must have done some practices with objective type questions well. So you need to take up such reference books, and plenty of questions will be available now. And go on solving this. It is really interesting to solve objective type questions. Immediate answer you will get, right? You need not wait for more time. Therefore, keep going. Solve. This is the time we have to go ahead with lot of questions like this, right? Right. Now, methanol and ethanol both are having OH, right? Methanol and ethanol both are having alcoholic group like this, and this by reaction with metallic sodium is not the answer, because both will give hydrogen. By reaction with caustic soda, NaOH, both will not react. Therefore, it is not the thing to take up. On heating with iodine in NaOH, iodine and NaOH, this is the way of distinguishing test also we have seen. This iodine in NaOH, what is this reaction called as? Where we use
Iodoform test,
NaOH?
sir.
Yes?
Iodoform test.
Iodoform test or haloform test. Iodoform test. So the compounds having this skeleton, I'll remind you, CH3, CH2OH. Okay, the compounds having this skeleton will give iodoform test. Second carbon having O, or two ketones or two alcohols, and ethanol and ethanol, all will give this CHI3. Therefore, this is the right answer. Iodine in NaOH is the answer. Okay, fine. Good, keep going. CH3CH2OH can be converted into CH3CHO, alcohol to aldehyde, by catalytic hydrogenation, treatment with lithium aluminum hydride, treatment with pyridinium, treatment with KMnO4.
Option C, sir.
Option C. Sure?
Yes, sir.
Sure, sir.
Sure?
Yes, sir.
Yeah, very good. Fine, fine. Catalytic hydrogenation. Catalytic hydrogenation is addition of H2. Look at this. CH3CH2OH, okay, is converted into ethanol. CH3C double bond OH. So here rather hydrogen is removed. Okay, from this to this, if you want to convert, this is the method. But ethanol to ethanol, this is not hydrogenation or lithium aluminum hydride. Straight away you can reject these two. Then on treatment with KMnO4, it is a strong oxidizing agent. It cannot stop at this, and it will produce ethanoic acid. Therefore, treatment with pyridinium chlorochromate, that is PCC, shortly called pre-CC, it's a mild oxidizing agent, we say. It converts alcohol into aldehyde, stops at aldehyde, not converting into carboxylic acid. Okay. In order to make alcohol undrinkable, pyridine, methanol are added to it. The resulting alcohol is called. Is it
Option C, sir.
okay?
Option C, sir.
Option C. Okay. I am finding there is some competition between another 2 or 3 schools only. Right? Other schools, come on, get up and give some response, and tell after the response what is your name of your school also. Right?
JNV Kadapa.
Yes, JNV Kadapa, good, fine.
JNV Vijayanagaram.
Vijayanagaram, good. Yes, yes, good. Yeah, I'm listening only the accent of Chikmagalur. That's why I thought like that. And Dharwad also is participating some extent. And Kadapa, Vijayanagaram, good. And any other school? So it needs, I understand, it needs the arrangement at the school also, right? And if the arrangement is there, only the students can participate. Otherwise, they have to mute spectators, whatever. But learn the things, that is the ultimate thing needed, right? So pyridine and methanol is added to denatured alcohol. Denatured alcohol, it is not power alcohol. Power alcohol is the one which is used in the replacing petrol, or it is added as an adduct in the petrol over alcohol. And denatured spirit is, it is made unfit for drinking, right? Pyridine gives the foul smell, and methanol is a poisonous one, and these are added to make unfit for drinking, right? Denatured spirit. Williamson synthesis is used to prepare acetone, ether, ether. It's a method of preparation of ether. Very good. Now more responses there. Good. Come on. Okay. I don't know whether you had morning tea or so, but you are energetic. Good. The cleavage of an aryl alkyl ether with cold HI gives.
Option D, sir. Phenol and alkyl iodide.
Aryl alkyl ether with cold HI gives. I give the clues. This H goes away here and binds using this electron. Now, whether this is undergoing cleavage or this is undergoing cleavage, you have to decide. If this doesn't undergo cleavage, and phenol will remain. If this undergo cleavage, then alcohol is being formed.
Option D, sir. Phenol and alkyl iodide. D. Option D. Phenol and alkyl iodide.
Okay. So this is considered to be the stronger bond because of R effect again. Therefore, this do not undergo cleavage. Therefore, phenol is one of the product. And then RI, alkyl iodide. Therefore, the answer is, sorry. Okay. Okay. Okay, I just wanted to stop. Okay. Yeah, this is what. Okay. Now, this is where I have right. Phenol and alkyl iodide. Alkyl alloy is used, right? Okay, hope you have understood this. Which of the following cannot be made by Williamson synthesis? Benzyl p-nitrophenyl ether, methyl tertiary butyl ether, ditertiary butyl ether. Which of the following cannot be bind? Ditertiary butyl ether. Okay. So in Williamson synthesis, okay, the halide should not be tertiary. Okay. The halide should not be tertiary. Okay. But in ditertiary butyl ether, the one to be taken is it should be tertiary halide only, because while preparing ether we need sodium alkoxide and alkyl halide. Both should be tertiary in case of ditertiary butyl ether. Therefore, this is not possibility, right? So this is the answer. Okay, fine. You have done wonderfully good. And we will go ahead with aldehydes and ketones and carboxylic acid, right? Right. What is formed when primary alcohol undergo catalytic dehydrogenation? Primary alcohol undergo catalytic dehydrogenation. Primary alcohol.
Option A, sir.
Catalytic dehydrogenation. So it's a primary alcohol. It will give aldehyde, right? It will give aldehyde. Okay. If it is secondary alcohol, it gives ketone, right? In this way. Which aldehyde cannot be obtained by Rosen-Munz reduction?
Option B, sir.
Option B. Okay. Rosen-Munz reduction is alkyl. Okay. Though this is acyl chloride. Acyl chloride, hydrogen, barium with palladium sulfate. Okay. Okay. Barium sulfate with palladium. Okay. Okay. It's not going. Whatever. Palladium and barium sulfate will give CH3 CHO, right? So for acyl chloride, this is needed. HCOCl doesn't react. Therefore, HCHO cannot be prepared. But CH3 is the minimum number of carbon atom here required is 2. Therefore, this HCHO cannot be. Okay. Aldehydes and ketones are distinguished.
B, sir.
B, sir. Toll's test.
Aldehydes and ketones are distinguished by Tollens test, right? Tollens test, correct? So Lucas test for primary and secondary alcohols, KMNO for solution, Bayer's test for finding out unsaturated. Therefore, this is Tollens test. A compound does not react with 2,4-dinitro phenylhydrazine. The compound is a compound does not react with 2,4-dinitro phenylhydrazine. The compound is acetone, aldehyde, ethyl alcohol, and propanone.
C, sir.
Methyl alcohol. Option C.
Yes. And one which is having carbonyl group, these undergo reaction with 2,4-dinitro phenylhydrazine. So the 2,4-dinitro phenylhydrazine is okay. So this is the NO2 group. This is NO2 group. This is NH-NH2. This is NH-NH2. Okay. A carbonyl group reacts with the hydrogen of this 2,4-dinitro phenylhydrazine. Therefore, the compound is C double bond N, H2 has gone, NH, okay, and benzene ring with 2 nitro groups, NO2 and NO2, right? So this is nucleophilic addition of derivative of ammonia. So this is derivative of ammonia, 2,4-dinitro phenylhydrazine. So this is not given by alcohol. Only those which are having carbonyl group, aldehydes and ketones will give, right? In which reaction C double bond O can be reduced to CH2?
Option A, sir.
Okay, option A. Any other answer? This is a C double bond O to CH2. That means aldehydes on ketones to hydrocarbons. There are 2 named reactions which does the same thing. So either it is Wolff-Kishner's Wolff-Kishner's reduction or reaction, or this is Clemenson's reduction. So what is the reagent used in the this Wolff-Kishner's reduction? NH2, NH2, hydrazine, then
Ethylene glycol.
yes, ethylene glycol plus KOH, right? So this in 2 steps will give this. What is Clemenson's reduction? What is the reagent? Clemenson's reduction. Okay, Clemenson's
Zinc amalgam.
Okay, so zinc amalgam HCl, ZnHg HCl, right? Right. CH3 thrice CCHO does not undergo aldol condensation due to 3 electron donating methyl
C, sir.
cleavage taking place between C-CHO bond, absence of alpha hydrogen atom in the molecule, bulky CH3 group, CH3 thrice group. What is the answer?
C, sir.
C, sir.
Okay. Simple.
Absence of alpha H.
Right. So this is CH3, 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 and CHO, right? So this functional group and this is alpha carbon.
Option C, sir.
Yeah, alpha carbon is not having hydrogen. If there is hydrogen in the alpha carbon, that is acidic. Alpha carbon is acidic. If alpha hydrogen is not there, then it won't undergo aldol condensation. Therefore, option C is the right answer. Right. Iodoform test is not given by. Iodoform test is not given by 2-pentanone, ethanol, ethanol.
D, sir.
Option D, sir.
Option D.
Option D, sir.
Yeah. 2-pentanone. 2-pentanone.
Methyl group is absent, sir.
Right. This is 2-pentanone. Ethanol. This is ethanol. Right. Ethanol, CH3, CHO. And 3-pentanone is having CH3, CH2, C double bond O, CH2, CH3. Okay. Now all these are having this skeleton, you can see. So remember and understand this. Okay. So, but this is not having. Okay. This skeleton, if it is there, it gives iodoform test. So writing the structure and coming to this conclusion is better than, right? 3-pentanone. When acetaldehyde is heated with
Option C, sir.
it gives a precipitation of
Option C, sir. JMENM.
Halling solution. Okay. It is Cu2O. Remember, it is Cu2O, right? Brick red PPT. Cu2O, not CuO. Canigerose reaction occurs with Canigerose reaction.
Option B, sir.
Option B, sir.
Option B, sir. Option B, sir.
Option B, sir.
Option B, sir.
Having
Option B.
alpha hydrogen. This is an alcohol, therefore not so. But benzaldehyde and formaldehyde. Okay. Benzaldehyde and formaldehyde, these two undergo Canigerose reactions. Canigerose reaction because they don't have alpha hydrogen. Right. Okay. Right. Ketones upon treatment with Grignard reagent gives. Ketone on treatment with Grignard reagent gives.
Tertiary alcohol, sir. Option C.
Option B, sir.
Ketones on treatment means important generalization, as I told you. Right? Tertiary alcohol. Right. When acetaldehyde reacts with alcohol, then produce.
Acetal, sir. Option A.
Okay. Acetaldehyde, CH3, CHO. This is acetaldehyde. Reacts with alcohol, right? Okay. So remember, this is reacting in this way. RO minus and H plus. This is plus delta minus delta. Okay. So this reacts with CH3. This is CH. And the one which is positive charge, this will go OR. Right? And one with negative charge, this plus will go. This is called hemiacetal. Hemiacetal. Right? So with alcohol, it will produce hemiacetal and acetal. Further, it reacts with one more ROH and produces 2 OR group, elimination of water. So hemiacetal and acetal are the product. So hemiacetal is not there. Acetal is only one is there. Therefore, that could be the answer. Okay. Clemenson's reduction of a ketone is carried out in the presence.
Option B, sir.
Option B, sir.
Okay.
B, sir.
HCl, right? Zinc amalgam HCl, right? I told you these are the very important questions, or very important to remember. Wolff-Kishner's reduction is reduction of carbonyl compound into alcohol, reduction of carbonyl compound into reduction of carbonyl compound into alkane, reduction
B.
of
Option C, sir.
compound into aniline.
C.
C is the answer. Okay, it is simple. Okay, I think you have done it. Right. Tollens reagent is ammonical
Ammonical silver nitrate, sir. Option B.
nitrate, alkaline containing complex of copper. None of this.
B, sir.
B,
Option B, sir.
silver nitrate. Tollens reagent, while writing the reaction, you are supposed to write like this: AgNH3 twice, having carry +1 charge, plus OH minus. This is the way you write. This is ammonical silver nitrate, right? Okay. The product obtained by the reaction of an aldehyde and hydroxylamine is?
Option B, sir.
Okay. Aldehyde and hydroxylamine. Aldehyde. Okay. And what is hydroxylamine? Hydroxylamine is NH2OH. This is hydroxylamine. Derivative of ammonia. This H2 goes away with this oxygen. Elimination. Okay. Nucleophilic addition with elimination of H2O will give RCH double bond NOH. NOH. This double bond will remain as it is. So this is called oxime. This is aldoxime. Aldehyde giving oxime is aldoxime, right? So this is the aldoxime. Methyl cyanide can be converted into acetic acid by one of the following reactions. Methyl cyanide
Hydrolysis.
can be converted into acetic acid.
Option B, sir.
Option B.
Hydrolysis.
Hydrolysis, electrolysis, decarboxylation.
Hydrolysis.
Okay. Let others also think like that. So this is C triple bond N. So what do you want here? You want ultimately CH3COOH, acetic acid, right? Cyanide on hydrolysis with 1 mole of water will give you amide, CH3CONH2. Okay. So hydrogen, 2 hydrogen and 1 oxygen added. So this is amide. This is called partial hydrolysis. When it reacts with 1 more moles of water, it will give CH3COOH plus NH3. So NH3 leaves here. So this is complete hydrolysis. This is giving complete hydrolysis, right? Cyanide to carboxylic acid is hydrolysis, important thing. Hydrolysis, this is the hydrolysis reaction with H2O. So reduction, but whereas reduction of this gives primary amine, CH3, CH2, NH2. So that can be carried out in the presence of lithium aluminium hydride. Okay. So they are very important reactions for the conversions also, right? So do remember. Fine. Toluene can be oxidized to benzoic acid by. Toluene can be oxidized to benzoic acid. PCC, both A and B, neither A and neither A nor B.
Option A is
A. Carboxylic acid, preparation of carboxylic acid. Come on. Tired or what? 8 o'clock. Okay. So this is KMNO4 KOH, right? KMNO4 KOH.
Yes,
So
sir.
it is little written in a different way. Alkaline KMNO4 it is being written. So KMNO4 KOH will oxidize benzylic carbon into carboxylic acid. Right? Come on. Boiling point of carboxylic acids are lower than the corresponding alcohols, higher than corresponding alcohols, equal to that of alcohols, none of this. So
B,
option
sir.
is available, I think higher than that of alcohols. It is higher than that of alcohols, right? Okay. Now coming to this. Which of the following acids has the smallest dissociation constant? Dissociation constant, that is Ka.
D, sir.
Option C, sir.
Option C. Who is saying the answer? Option C.
JNP Vizianagaram, sir.
Vijayanagaram. Okay, fine, fantastic, right. Okay, so this is absolutely based on this is smallest. It is given as the smallest, right? So out of fluorine and bromine, fluorine is more electronegative, bromine is less, right? And because of this, you should choose either this, okay, or this. Now, out of these two, bromine is nearer to COH, and in this compound, bromine is just away from COH, right? One which is nearer to COH, it gives added effect, okay, the electron withdrawing effect. But if it is more, the electron withdrawing becomes smaller. So this is the right option. BR is the C is the correct option, right? The major product of nitration of benzoic acid is the major product of nitration of benzoic
Option
acid
D.
is. So you must know whether COH is a meta director or ortho para directing. This is meta directing. This is meta directing group. 1, 2, 3. This is the nitration product. COOH, CHO, aldehyde, carboxylic acid, and NO2. All these are meta directing. Therefore, this is the product. So 3-nitrobenzoic acid is the answer, right? Among the following acids, which has the lowest pKa value? pKa value. I told you that the question can be asked in this way. pKa value.
C, sir.
Now, first you can identify which has got greater Ka value. The greater Ka value has got lowest pKa value. The greater Ka value means which is more acidic. COOH, right? Okay. Or carboxylate ion. You can take whenever it is an acid, then it is a carboxylate ion. Right? So this is having electron cloud in this way. Electron donating group destabilizes this so that less is the acidic character. Alkyl groups are electron donating groups. I think this much clues are enough. Therefore, which could be the stronger acid? HCOH is a stronger acid. Here one CH3 is there, electron releasing. CH3 twice, isoprofile group is there here. Right? And here is ethyl group. All these are electron donating only. But this is having higher Ka value, therefore lower pKa value. Right? That's how we have to answer. A carboxylic acid can be converted into acid chloride by using
All of the above.
Yes. All the above is the right answer. Good. So you are remembering. Fantastic. RCOH, carboxylic acid, is converted into acid chlorides. RCOCl. RCOCl, say, acid chlorides, right? So this OH is to be removed, right? For that, you can use either PCl5, PCl3, or SOCl2. These are the reagents. Okay. Alcohols with this reagent will give alkyl chlorides, right? With this reagent, alcohols will give alkyl chlorides. Carboxylic acids will give acyl chlorides, RCOCl. So that differences you have to remember. These are the reagent, same reagent. Even in the first chapter, we have used that. Now, benzoic acid may be converted into ethyl benzoate by reaction with.
Yes, sir.
Okay. Okay, I will give that. Benzoic acid, this is benzoic acid, right? Converted into ethyl benzoate. Ethyl benzoate structure is CO, C2H5, ethyl benzoate, COO.
C, sir.
C2H5. This is the compound to be converted. So which class of compound is to be added? Always remember, a carboxylic acid with alcohol will give an ester. Carboxylic acid with alcohol. It should be a alcohol.
Esterification.
Okay. Alcohol, or it can be. Okay. So what is this? An alcohol plus H2SO4. Acid catalyzed. Yeah, it is there, no? I'll come back. Okay. It's there. Ethyl alcohol plus H2SO4. Okay. It's not ethyl chloride or sodium ethoxide. It is ethyl alcohol plus H2SO4 is the right answer. Okay. Propionamide on Hoffman's degradation gives propionamide.
B, sir.
B, sir.
B? Yeah. So this is
B, sir.
Hoffman's bromide degradation. Therefore, CO will go. One carbon atom less. Prop is there, means it should be eth. Therefore, it is the right answer. Gabriel phthalimide synthesis is used for the preparation of Gabriel phthalimide synthesis.
C, sir.
Okay. Good.
C,
So,
sir.
Gabriel phthalimide synthesis, we use phthalimide, CONH. This is phthalimide, right? So this is converted into, right, CON, okay, NH is converted into NR, right? So at the bond afterwards, it will be, okay, NK, and afterwards NR, okay, in two stages. This bond, this RN bond, is only one bond with N is possible. And these bonds will be replaced by hydrogen at the end. Okay. So this will be only primary amine. This can be only primary amine because only one alkyl group can be added. So it is only primary amine. And it cannot be a benzene ring also, aryl group also. Aromatic is not possible because aromatic halide that you are adding is having plus R effect, because of which we cannot use that. Therefore, only primary aliphatic amines are produced by Gabriel phthalimide synthesis. Okay, fine. Okay. Coming to this, the next question. Ethylamine reacts with HNO2 give. Ethylamine with HNO2. Ethylamine with HNO2. Nitrous acid. NaNO2 HCl.
A, sir.
Okay, this is HNO2 is prepared in this way. HNO2. So gives alcohol. Remember, it gives alcohol, right? Diazonium salt supposed to, but diazonium salt is unstable and produces alcohol. But whereas if it is an aryl amine, that is aniline or so, then it will give benzene diazonium salt. But benzene diazonium salt, when it is heated also, it will give phenol. Okay, there is no need of heating. At this temperature only, it will give alcohol. Okay. Okay. NH2 group in aniline is. NH2 group in aniline is.
Ortho direct.
D, sir.
E, sir.
Is it right? Ortho para directing. NH2 is ortho para directing. Okay, all this, remember. Whatever the halogen, okay, I'll take it as a halogen in haloarenes. Okay. Phenol, OH, anisole, okay, and NH2, all these are orthopara directing groups. Okay, benzene ring, if these are there, then they are orthopara directing. Okay, only CHO, COOH, this is meta directing. Okay, from this, from the chapters that you have, this is the point to remember. Primary amines can be distinguished from secondary amines and tertiary amines by the reacting with.
Yes, sir.
A, sir.
Okay, fine. Fine. You identified very quickly. Chloroform plus alcoholic KOH, CHCl3 plus KOH. What reaction is this if this reagent is used?
Carbylamine.
Amines. Yeah. Primary amines with this reagent will give RNC. So this is offensive smell. Through the smell we identify, right? Therefore, this is a distinguishing test. Okay. CH3 twice. CHNH2 is reacted with 1 mole of acetic anhydride. The compound formed is
Option A, sir.
CH3 twice CHNH2 is reacted with 1 mole of acetic anhydride. Option
B, sir.
Okay. See, this is CH3 twice CHNH2, right? This reaction is with acetic anhydride. Acetic anhydride is CH3CO twice O. Acetylation takes place. The other things of alkyl group will remain as it is. Okay, this will remain as it is. CH. This will form NHCOCH3. NH, this is called acetylation. Okay, and another product is CH3COOH. One of the hydrogen is removed, right? So this is the product which is being formed, right? Okay, the reacted 1 mole of acetic anhydride compound formed is therefore CH3 twice CH NHCOCH3. NHCOCH3 is the A. Fine. Replacement of N2Cl from benzene diazonium chloride by iodine be done by using
A.
diazonium chloride,
D, sir.
iodine.
D, sir.
Yeah. Is it B? A replacement of, this is diazonium chloride, benzene diazonium chloride by iodine. This is to be replaced by iodine. Okay, what is the reagent used? Now you tell me. Is it A, B?
D, sir.
D. It is Ki and heat.
D, sir.
Okay. Ki and heat will give iodobenzene. For getting chlorobenzene, CuCl, HCl, right? Bromobenzene, CuBr, HBr. But iodobenzene, Ki and heat. Okay, therefore D is the answer. When phenol and benzene diazonium chlorides are coupled, the main product is phenol and benzene diazonium chloride, right? This is benzene diazonium chloride
B, sir.
B, sir.
plus phenol plus phenol. This hydrogen goes away. This hydrogen goes away. And this is called coupling reaction. Okay. This is N2 and OH. So this is p-hydroxyazobenzene. P-hydroxyazobenzene is formed. Right. Which of the following reagent can be used to convert benzene diazonium chloride into benzene?
B.
Benzene diazonium chloride into benzene. There are two reagents. One is this and another is ethyl alcohol, H3PO2. But only one thing is being given here, right? The correct order of increasing basicity methylamine, ammonia, and aniline is methylamine, aniline, and ammonia.
Option B, sir.
Option C, sir.
Option C, right? Aniline,
B, sir.
B, sir.
okay. Methylamine, ammonia. Methylamine. Okay. Alkyl amines are electron releasing and chances of giving the electron is more. Okay, this has no effect, but it has. Okay, this is the order. So aniline, okay, it is the increasing order of basicity. Aniline should be then NH3. Ammonia should be there, and B is the option, right? B is the answer. Amine that cannot be prepared by Gabriel phthalimide synthesis is amine that cannot be
Yes, sir.
prepared by
Aniline, sir.
aniline. Okay, benzylamine can be prepared. It's a primary halide. Benzylamine, methylamine, isobutylamine can be prepared. Aliphatic primary amines can be. Okay. Okay, this is benzyl is like this. Remember, this is benzyl. Okay. So if it is not directly not attached, then we can able to prepare. Right. Which of the following statement about the primary amines is false? Alkyl amines are stronger bases than aryl amines. Alkyl amines react with nitrous acid to produce alcohols. Aryl amines react with nitrous acid to produce phenols. Alkyl amines are stronger bases than ammonia.
C, sir.
Okay, C, because aryl
sir.
amines react with nitrous acid to produce diazonium salt, benzene diazonium salt. Only alkyl amines will produce alcohol, but aryl amines will give benzene diazonium salt. Very good. Good participation. You are keeping energy. Good. Primary amines is formed by amide on the treatment with bromine and alkali. The primary amine has
Carbon atom.
Option A, sir.
Yes, sir.
okay, one carbon atom less than amide. Okay, this is about Hoffman's bromide. Hinsberg reagent is
C, sir.
Yes, sir.
C.
C, sir.
It is
C, sir.
C. Benzene sulfonyl chloride. Benzene sulfonyl chloride. Okay. C6H5SO2Cl is the structure of it. The amine that does not react with acetyl chloride. Acetyl chloride.
C, sir.
This is acetyl chloride.
C, sir.
See, because to react with, there must be hydrogen. This Cl will react with hydrogen. Okay. The hydrogen must be there. Here it is one hydrogen left means NH will be there. One hydrogen is there. Here no hydrogen. Right. The correct order of increasing basicity of methylamine, ammonia, and aniline. I think it is being already told. Phenol benzene diazonium chloride is coupled. Okay, this is also over. I think it is 2 times it is being. IUPAC name of diethyl isopropyl amine is diethyl isopropyl amine.
C, sir.
Fine. Who said the answer?
Vijayanagaram, sir.
Jane Vijayanagaram. Very good.
Option A, sir.
Okay. The one which is having more number of carbon atoms to be chosen for world root. Therefore, it is isopropyl.
Yes, sir.
Isopropyl is used in IUPAC. Okay. Or it can be propane 2-amine. It can be told also. So NN diethyl isopropyl amine. Isopropyl amine. Okay. So C is
Yes,
the right
sir.
answer. Right. Okay. Yena. Okay. Propane 2-amine. Isopropyl. Okay. Isopropyl and propane 2-amine, if it is present, then we have to take A. Right. Isopropyl is sometimes used in IUPAC also. Of course, both can be the answers here, but this is more appropriate. Propane 2-amine is more appropriate. Amine that cannot be prepared by okay, I think it is repeated. Acetamide on treatment with the following reagent separately, which one of these would yield methylamine? Acetamide treatment with reagents separately.
Yes, sir.
Yes, sir.
Okay, will give methylamine. Acetamide is CH3CONH2. This is acetamide. Okay, so common name. And which gives CH3NH2? This is methylamine. That means this has gone. NaOH-Br2 is Hoffman's bromide degradation. Therefore, this is right. Okay, questions from sample papers, right? I will quickly look into that. Which of the following is not correct? In haloarenes, the electron pairs on halogen atoms are in conjugation with pi electrons of the ring. The carbon-magnesium bond is covalent and non-polar in nature. During SN1 reaction, carbocation formed in the slow step being sp2 hybridized is planar. Out of the CH2 double bond CHCl and C6H5CH2Cl, C6H5CH2Cl is more reactive towards SN1 reaction. Which one is not correct?
D, sir.
Out of these two, this is SN1. See, remember, this is vinyl chloride, right? Vinyl chloride is not undergo this at all. Okay, fine. Okay, and this is a primary halide. Therefore, this is true, right? During SN1 reaction, carbocation formed in the slow step is being sp2 hybridized planar. That is right, because carbocation, it is a carbocation. But carbon-magnesium bond is covalent and non-polar in nature is not there. It is a polar. It's a polar covalent bond. Magnesium being more electronegative, right? More electropositive, right? Now, which of the following observation is shown by 2-phenylethanol with Lucas reagent? Observation is shown by 2-phenylethanol. 2-phenylethanol. Okay. So this is 2-phenyl. Turbidity will be observed within 5 minutes. No turbidity will be observed. Turbidity will be observed immediately. Turbidity will be observed at room temperature, but will disappear after 5 minutes.
B, sir.
Yes,
Okay,
sir.
no turbidity is formed at room temperature because it is a primary alcohol. Okay, primary alcohol. Remember that. Drawing the structure is therefore important, right? Drawing the structure is important. For primary alcohols with the Lucas reagent, no turbidity at room temperature, right? So these are the questions of sample papers, latest sample papers of the examination, right? Okay, so assertions and reasoning questions. Okay, we will take up in the later. Okay, one question I will deal with. Strong oxidizing agents will oxidize toluene and its derivatives to benzoic acids. Strong oxidizing agent oxidizes toluene and its derivatives to benzoic acid. Reason: it is possible to stop the oxidation of toluene at the aldehyde stage with suitable reagents. Whether both the sentences are correct. So this is right. Toluene is converted into
Option B,
benzoic
sir.
acid. This is right, but this is wrong because we can, with the strong oxidizing agent we cannot stop at aldehyde, right? So R is wrong. R is false. Okay, so this is the answer. Okay, so okay, fine. So we have solved the questions, objective type questions present in the latest CBSE PAMSO papers also. Keep in touch with such kind of questions. Okay, and keep going. And we will see in the next session. Meet you in the next section. Thank you.
Sir,
Pardon me?
reagents we can convert toluene into
Toluene or its derivatives, maybe toluene, chlorotoluene. Okay, if it is chloro, that also can be converted into benzoic acid because carbon at the benzylic hydrogen is necessary for conversion into benzoic acid. KMnO4 KOH is the reagent, right? Yes. Okay. Mhm. Okay.
Thank you, sir. Bye.
Okay. Thank you. Thank you. Thank you. Bye.
Bye, sir.
Bye.